In this particular video, we are going to discuss about Docker containers. What exactly is Docker container and how the container work and what is the use cases of containers and in practically how to work with the container and also some use cases and some example as well as some tips at the end of the video. Okay, let's start the video. First of all, what exactly the Docker container is? So basically, just as a non-technical example, think of it like a shipping container. How the containers is there in oceans like that. Okay, just like a shipping container can hold anything and be moved anywhere. A Docker container packages your application with everything it needed to run, making it portable, access any environment. This is a small technical, non-technical example how you can correlate with the real containers with the Docker containers. Okay, how it was carrying a goods and it was moving to anywhere. So likewise here it was carrying with the application and its dependencies. Okay, so basically whoever accessing those, they can access the application and they can run the over container. It is like that. Okay, and if you see some use cases, we are going to talk about this very deeply. On a high level, I am just discussing. It is lightweight, where it will share a OS kernel, and it is very faster than virtual machine. And portability is there, where it will runs anywhere Docker is installed, and it is fast, which is a quick startup and deployment, and consistent. It will share a consistent behavior across the different environments like dev, production, testing like that, and packaged as we know, like it will package the all application dependencies and runtime and isolated. Okay, so basically isolated, which is maintains a independency from host. Okay, and but it utilizes the host mission resources. That is how it maintains a isolation. And coming to the next slide, if you see how exactly the containers work. Okay, sorry, yeah, how exactly the containers work. So there is a life cycle of container where we have your Docker file image. Okay, sorry, a Docker file, it's not an image. Then we are going to build that Docker image, Docker file, then we get a Docker image. Okay, and then we are going to run this particular Docker image, then we will get a container. Okay, so for Docker file, as we need to write a raw file. Okay, with from copy, mkdir, entry point, cmd, expose, like that commands will be there. Okay, and then we are going to build. Okay, in between Docker file and image there is a build option. Okay, after that build only the Docker file image is created with the help of file. Okay, and then from image to container there is a option called run. Okay, here run option will be there, and don't consider about handwriting, and here build option. Okay, and if you see kind of example, also example and non-technical analogy, Docker file is like a blueprint with the instructions. Okay, that is this one. Okay, it is just a kind of instructions only, and image is read only template. Okay, and it is not running, it is only read. Whatever blueprint is there, that is deployed into a image, but it is read only. And container is running instance of an image. Okay, when it is like static condition, it is the image. When it is a dynamic condition, then it is a container. That is only the difference. Okay, and moving to the layered architecture within your Docker. Okay, so how exactly the container will work and what is the layers in that. Okay, so as we know, like Docker container is like uh, advanced or some replication of your virtual machine. Okay, so but there is a small changes. If you see the layers, there is a base OS layer, which is our own system layer, okay, and then runtime layer, okay, and then dependencies layer, where all dependencies will be maintained here, and then application layer, okay. Here in application layer, the Docker container will come into picture, okay. So but if you see in the, I mean, in the application layer, Docker will do a application layer virtualization, okay, but in the virtual machine it does a OS layer virtualization. That is the difference, okay. And here if you see here, isolation, each container has its own file system, network and process, but shared the host OS kernel. That is the like difference. On top of OS kernel only, we are going to install a Docker image, Docker engine, and then we are going to perform if you are in base image, okay, sorry, if you are in a laptop or PC, okay. And moving to the next slide, why to use a containers. As in the first slide we have discussed about some pointers in the high level. Now we are going to deep dive, okay. First one, it is consistency. Consistency is basically, uh, you may heard it works on my machine, and it's not working in your machine. That problem will be resolved, okay. Why? Because developer is going to maintain a kind of dependencies, and he will test in their environment, and then that will be built to a image, and that will be deployed into a Docker registry. It is Docker hub. So then, like cross-functional team, like a testing team or production team, they will pull the same container, okay. And here the same environment anywhere, by this basically in the production testing and development, the the environment makes similar, okay. And coming to the second point, which is portability, which means run anywhere Docker is supported, okay. That might be cloud or on-prem or developer's laptop, anywhere. And isolation, applications don't interfere with each other, where we are going to with the security and the stability will be maintained. That is the also one of the main feature of Docker container. And scalability can be done, which is easy to scale up or scale down, and we can spin up multiple containers instantly whenever it is required, okay. And also resource efficiency, we can better utilize the resources than the virtual machines, and it is lighter footprint will be created. And coming to the DevOps benefits, it will be faster deployment and easier for CI/CD, and simplified environment management, okay. These are the some real use cases of your containers, okay. And moving to the next slide, which is working with the containers, okay. Here, whenever if you wanted to run your container, let me take another pen, yeah. Here if you wanted to run your container, then you need to use this particular command, okay, to run your container. Docker run -d -p 8080 nginx. Till this, the command will be same, okay. And here we can give any port, and then this is our image name, okay. Here basically -d is detached mode, which runs in the backend. -p, which is the port mapping. If you don't map the port, you are not supposed to access that in your host machine, okay. And to stop the containers, this is the command to run your container, basically to start your container, and this is to stop a container, okay. Docker stop, and then container ID name, okay. Once we start a container, it will create a container ID, so with the help of that ID we can stop the container, and we can also give a name, and with the help of name also we can stop, okay. And then docker stop dollar docker ps -q, okay. Basically it will stops the all container, it will stop only single container, okay. And it will stop all the containers, okay. So this is basically a difference. And coming to the docker listing commands, docker ps will list the running containers, and docker ps -j will list all the containers irrespective of the state, okay. And to remove a container, this is a command docker rm and container id to remove a single container, okay, that particular container only. And if you use docker rm $docker ps hyphen aq, then it will remove entire containers, okay, irrespective of running, stop, any state, okay. And if you see the common workflow of the docker, basically we are going to sometimes build a docker image from scratch, or else we are going to pull from the docker registry, which is the docker hub, and then we are going to run, okay. This is the first step, and then we are going to run, that is the second step, and then we are going to monitor or debug, which is third step, and then we are going to, once the work is done, we are going to stop or remove the containers, okay. That is the fourth step. And here whenever you are working with monitor and debug, you will get to know like a lot of commands, like setting up the volumes, setting up the different networks, checking the logs, different commands we will get to know, okay. And docker use cases, basically docker has multiple use cases like microservices, testing, ci/cd, cloud migration, development, database, web application, like that. So we'll discuss one by one, okay. So basically docker web application, okay. So in the web application, how the docker is like helpful, we are going to deploy a web server like nginx or apache, or apis, and full stack applications with a consistent environment across the development and production, okay. So web application will be consistent among the like any phase, okay. And coming to the second one, which is database, so we can deploy any isolated database, and we can also maintain your version management, and then microservices, basically we can break the monolithics into a small pieces, which is the microservices. Each service runs in its own container, okay. So we are not supposed to create a big container with high configurations. We are going to separate them into a microservices, small, and then we are going to put each microservice into each container, okay, which enables a independently scaling, and deployment will become easy, okay. And coming to the development stack, okay, where developers get identical environments without complex local setups, that is the like use case here. And for testing ci/cd, like automation testing in isolated environments like Jenkins ci/cd, GitLab ci/cd, GitHub Actions, use containers for build and test process, okay. And the cloud migration, where we are going to containerize the legacy applications for cloud deployment, and easy migration between the cloud providers, AWS, Azure, or GCP will be happened smoothly. And moving to the next slide, which is sorry, yeah, uh, if you see here, we are going to see a quick small kind of example, where to create a web application container, okay. So this is the command starts here, don't confuse, docker run -d 8080, that means 8080 will be the host port access, and 80 will be the container port, okay. And then you are giving name my web to the nginx image, okay. And then to check here running, uh, to check if it's running, okay, basically if the container is up and running or not, we'll get to know with the help of this command docker ps. And to view the logs, this is the command docker logs your container name, okay. And to execute a command inside a docker, okay, that means to basically enter into a container, this is the command docker exec -it web app, which is your container name, and bin bash, like that you will use, okay. And stop and remove a docker, basically to stop and remove, this is the command, both will be done in single command by using and, okay. Earlier we have seen commands separately, now as a single command, docker stop and your container name, and docker rm, which basically stops here, which basically removes here. If you directly use this command, it will stays, uh, it will says it is running, we cannot remove like that, okay. Then you need to use a forceful command, okay, -f, then it will remove. And coming to here, some common interview questions. What is the difference between image and container? Basically, image is a template and a container is a running instance. Docker versus virtual machine, what makes the difference? Basically, Docker shares a host kernel. Virtual machines separate its OS. Okay, virtual machine will install its own OS on top of base machine OS. What is Docker file? Basically, Docker file is a text file instructions to build a Docker image. And Docker networking. Basically, Docker networking have a by default bridge, host, and overlay networks for containers to communicate each other. And some best practices here. We are not supposed to use latest command, latest tag when image whenever you are pulling or building or running. Okay, and keep the containers stateless. Basically, stateless in the sense we are not storing the container like like data or logs. Why? Because whenever we restart or rebuild a container, the data will be lost. That is the one. Okay, instead of this, we can use the volumes. That is the option. Use Docker ignore file. Okay, we'll discuss about this in later. And multi builds for basically it will ignores the whatever the files which is in unnecessarily. Okay, and multi-stage builds for smaller images. Okay, whenever you use multi-stage builds, the image layers will be reduced, and it is also one of the best practice to follow in your Docker file and containers. Okay, yeah, I think we are good to conclude for this video, and stay tuned for more videos. Thank you so much for watching the video.